Alright guys, so this is the video for section 4.9, and in this section you are going to need your graphing calculator. We're going to use it quite a bit. So make sure you have that handy. If you don't get it, if you do, great. But most of this section is going to use that graphing calculator. Most of it's review. Okay, but if we look at example 1, this is not with your graphing calculator, one of the few things on here. So let's go over how to do it. Okay, so we want to write the cubic function. So cubic, remember, that's a degree of 3. And we want to write it in factored form, which actually makes our life a little bit easier. Okay, so if we look at this graph, we want to write the equation of this graph. Okay, now, as you can see, we have our 1, 2, 3 x-intercepts. Okay, so we have x-intercepts at -4, at 1, and at 3. Okay, which means those are actually our zeros as well. So if those are our zeros, that means that we have the factors of x plus 4, x minus 1, and x minus 3. Okay, so that should be a review for you. So if we write this equation just with what I have, we don't have everything yet, but f of x is going to equal some number out here, and then x plus 4, x minus 1, and x minus 3. Okay, now our goal is to solve for this a. Okay, now notice in this graph we have 3 x-intercepts, but we also have the y-intercept. Okay, now I just want to note that when we do this, we don't have to have the y-intercept. Okay, any other point on this graph other than the x-intercepts will work. Now, it makes our life easier if we have the y-intercept, but any other point would work. Okay, so from this y-intercept, we know, or we should know, that if we plug in x, we should get what value out. Okay, if we knew this, if we knew our value of a, if we plug x in, what should our y be? Okay, it should be 16. We should, or sorry, -6. We should get -6 out. Okay, so we can go ahead and show that over here. So if we plug 0 in for x, so a times 0 plus 4, 0 minus 1, and 0 minus 3. If we plug 0 in for 1, we should get -6. Okay, well, now that I have all that plugged in, notice a is my only variable, so I should be able to solve for that. All right, so -6 equals a times, well, this is just 4, this is -1, and this is -3. Okay, 4 times -1 times -3 is what? Positive 12, so -6 equals 12a. And then to get a by itself, just divide both sides by 12, and you get a is -1/2. Okay, so if I want to go ahead and write this whole function, it would be f of x equals, well, our a is -1/2, then it'd be x plus 4, x minus 1, and x minus 3, and that would be our final answer. All right, so let's look at part B. Now, part B is the same way. We're going to write a cubic function, so once again, a degree 3 that passes through these given points. Okay, now notice this is an x-intercept, this is an x-intercept, and this is an x-intercept. Okay, I know those are x-intercepts because my y values are 0. Okay, so I can start with f of x is going to equal some number a times x plus 4, x minus 2, and x minus 5. Okay, now I want to use the other point that's not a 0, so this point here, to find my a. So I can plug this in for x and this in for my y, or f of x. Okay, so 10 equals a parentheses 0 plus 4, 0 minus 2, 0 minus 5. Okay, so to simplify, 10 equals a. This is just 4 times -2 times the -5. And if I multiply all these out, -2 times -5 is a +10. +10 times 4 is 40. So 10 equals 40a. To get a by itself, divide both sides by 40, and you get 1/4, or a is 1/4 or 0.25, whichever one you want to write. Okay, now that I have that, I can write my entire function. So f of x equals 1/4 x plus 4, x minus 2, and x minus 5, and that should be your final answer. Okay, now there's a monitoring progress down here if you're struggling or if you want to practice. These aren't that bad, but I encourage you to go ahead and pause this video and work this out. Okay, and then unpause it and I'll show you the solution. All right, so this is what you should have gotten for the monitoring progress. Okay, now the ones in purple, those are my x-intercepts, which means I have a factor of x plus 1, x minus 2, and x minus 3. Okay, so from just that, I get this equation in blue. Okay, now the other point that I have that's not an x-intercept is this 0, -12. Okay, so if I plug my 0 in for x, my -12 in for y, I get this. Okay, and then I just solve for a, and I get a to be -1/2. Okay, after I get a is -1/2, I just plug it in over here, and my equation should be f of x equals -2 parentheses x plus 1 parentheses x minus 2 parentheses x minus 3. All right, so here's some review for us, okay? And this goes back to your graphing calculator, so once again, make sure you have your graphing calculator. Okay, it says, the distance a baseball travels after it is hit depends on the angle at which it is hit and the initial speed. The table shows the distances of a baseball hit at an angle of 35 degrees, that an angle of 35 degrees travels at various initial speeds. And then it gives us this chart here. Okay, so if we keep going, it says recall that, here's kind of the review for you. Okay, recall that when data have equally spaced x values, you can analyze patterns in the differences of the y values to determine what type of function can be used to model the data. If the first differences are the same, the data fits a linear model. If the second order differences are constant, we have a quadratic model, and then we had talked a little bit about if the third are constant, it'd be a cubic model, the fourth are constant, it'd be a quartic model, and so on and so forth. All right, so let's look at this. Okay, so something that I need you guys to remember is that in order for to do these first, second, third order differences, our x values have to be equally spaced. Okay, and what I mean by that is like in here, we're increasing by a constant increment of 5. So 80, 85, 90, 95, 100. So when that happens, we can check for our first, second, third order differences and so on. Okay, and it doesn't have to be by 5. It can be by 1s, 2s, 3s. It doesn't matter, but it has to be consistent. Okay, so if it's consistent, then we look at our y values. Okay, so down here, we just made our y values. So 194, 220, 247, and so on and so forth. Okay. Now, as hopefully you remember, when we did this, what we want to do is this line is going to be our first order difference. This line is going to be our second order difference. And then we can actually go on and find the third order, fourth order, fifth order if we needed to. Okay, so all we're going to do is we are going to compare these two. We're going to find the difference in these two numbers. Okay, so basically if I go from 194 to 220, I'm increasing by 26. Okay, and then if I go from 220 to 247, I'm increasing by 27. Okay, if I go from 247 to 275, I'm increasing by 28. I'm increasing by 29, increasing by 30, increasing by 31, and increasing by 32. Okay, now these are not the same, but there is a definite pattern. Okay, there won't always be a definite pattern, but here there is. So the first order difference, we call that, these are different. It's not the same number, and therefore we know it's not linear. Okay, remember that if the first order difference is the same, we have a linear function. Okay, so now we want to find the second order differences. So now we're going to compare this line. Okay, so going from 26 to 27, we just increased by 1. Okay, going from 27 to 28, we increased by 1. 28 to 29, we increased by 1. 29 to 30, increased by 1, and we increased by 1 all the way across. Okay, now the second order differences are the same. And as you recall, if the second order differences are the same, we have a quadratic function. It's a perfectly quadratic function. Okay, we could write a quadratic function that fits this model perfectly. All right, so with that in mind, let's look at example 2. Okay, now example 2, it says use finite differences to determine the degree of this polynomial function that fits the data. Use technology to find the actual function. Okay, so when I look at this, the first thing I want to do is I want to look at my x values. 1, 2, 3, 4, 5, 6, and 7. So I am increasing by 1 as I go. Okay, so therefore I can look at the order differences. Okay, so if I look at the order differences, from 1 to 4, I increase by 3. From 4 to 6, I increase by 6. 10 to 20, I increase by 10. 20 to 35, I increase by 15. Here, I increase by 21. And from 56 to 84, I increase by 28. Okay? First order differences are not the same, therefore we know it's not a linear function. Okay, so then I want to go another one. So 3 to 6, I increase by 3. 6 to 10, I increase by 4. Increase by 5. 15 to 21, increase by 6. And increase by 7. Okay, so my second order differences are not the same, so I want to try my third order differences. 3 to 4, I increase by 1. 4 to 5, I increase by 1. 5 to 6, increase by 1. And 6 to 7, I increase by 1. Okay, my third order differences are the same, and therefore I have a perfectly cubic equation. All right, so if you look at example number 2, okay, let's go ahead and find the exact equation of it. Okay, we know it's a cubic function. So go ahead and hit the stat here, edit, and we're going to put all our x values in L1 and our y values in L2. So I'm going to go ahead and pause this and do that real quick. Okay, so after your L1s and L2s are filled in with your x's and your y's, okay, once again, just like we did before, we're going to go to stat. But this time we want to calculate, and because the third order differences were the same, we want to calculate the cubic regression. Okay, we've used linear regression, we've used quadratic regression, now we're going to use cubic regression. So hit enter. Okay, then you have to hit enter a few times till you get to calculate. Now here is your equation. Okay, so remember we're going to do cubic. So here's our A, B, C, and D. So if we write that, we can write f of x is going to equal 0.167x cubed plus 0.5x squared plus 0.33x plus 0, or just like this. Okay, and there's your line of perfect fit for this. If you want more practice, I encourage you to do this monitoring progress, so just plug it into your calculator like before. We'll first find the order differences, then plug it into your calculator, and then find your polynomial function. All right, so this is the answer here you should have gotten for the monitoring progress. Okay, now you first should have looked to make sure these all increase by the same number, and they do, they all increase by 1. Okay, and then you need to find that the third order differences are the same. Okay, and so you put this in your calculator, go to cubic regression, and this is what your calculator should spit out at you.